Spanning tree LoopGuard is Cisco's security-related enhancement to the traditional spanning tree. It is designed to prevent the loops in a case that BPDUs are suddenly lost. What I mean by that is that in normal operation in our network, ports that are designated ports are going to be forwarding the BPDUs sent by the root. The downstream ports, the root ports on the downstream switches, are going to be receiving these BPDUs and are going to be treating their ports as either root ports in this case, or in a case that this is not the best path to reach the root, these ports are going to transition into the blocking state. What maintains this state, either the root port or the blocking port, is the presence of the BPDUs coming from the upstream switch. If these BPDUs were to suddenly stop arriving, these ports, the root ports, may become designated ports, or the blocking ports may become designated ports as well. In a case that root port transitions to become a designated port, we don't have much danger in case because this port was forwarding to begin with. But if the blocking port was to change state to forwarding, and the upstream port was still operational, just for some reason we were not receiving BPDUs being sent by it, or they may be filtered by the upstream port, we are running the danger of creating the loop in our network. So the absence of BPDUs may signal a problem in our network. And the LoopGuard is the feature designed to prevent this particular thing from happening. Now, I should point out that the LoopGuard is a very, very complex feature. It takes many things into account. From a configuration perspective, it's very simple to configure. We can configure it either on a per port basis, or we can enable it globally, which turns it on all the ports on the switch. But the ports on which this feature is actually going to be enabled on are only non-designated ports that are already receiving superior BPDUs. That means that if port is transitioning from a disabled state, say going from shutdown, and we just simply type no shutdown, and we are not getting any BPDUs from the downstream device, whatever it may be, we are not going to transition this port into the blocking state. Why? Because we haven't received any BPDUs, any superior BPDUs, to compare them to what we have. Also, if the device on the other side is sending BPDUs that are inferior to the copy of the BPDU that we have from the switch that is root in our network, we are also not going to block this port because we are receiving inferior BPDU. The poor guy on the other side doesn't know who the root is. We should better tell him that by forwarding our own BPDUs. Also, this feature, the LoopGuard, is mutually exclusive with the RootGuard. To do that, I'm going to switch to my whiteboard and look at the example network. I'm again going to be using just 3 switches. I'm going to have Cat1, Cat2, and Cat3. In this setup, Cat1 will be configured as the root, and the switches are going to be interconnected in a triangle like this. This is going to be Gigabit 01 on both sides here. This is going to be Fast Ethernet 22. And this here is going to be Fast Ethernet 20 port. Given this topology here, this port will be designated port, this port will be designated, these 2 ports will be the root ports, this will be a designated port, and this one here will be the blocking port. And the good candidate in this network for the LoopGuard feature would be this port here. We want to prevent this port from transitioning into the forwarding state if this port here is up, but we are not receiving BPDUs from the other side. But as you will see, actually replicating this is going to get a little bit involved because of all those complex requirements for the LoopGuard to become active. Let me show you what I mean. In the first example here, what I'm going to do is I'm going to start by enabling LoopGuard on Fast Ethernet 20 on Cat3. And then I'm simply going to shut this link down on either Cat2 or Cat1. And I want to see what's going to happen. before I do that, I'm going to enable a simple debug process on Cat3. I'm going to say debug spanning tree events. This will show me when ports transition between the states or when I start receiving inferior BPDUs from somewhere. As I can see, in normal operation, this command is going to be relatively silent. The next thing that I'm going to do is I'm going to go to interface fast-internet 20 and I'm going to say spanning tree guard loop. Now I have turned on the LoopGuard on this port. I can confirm that if I run show spanning tree interface fast-internet 20 detail, I will see here that the LoopGuard is enabled on this port. Now I'm going to go to Cat2 and I'm going to shut the link down between Cat1 and Cat2. When I do this, on Cat3, I'm going to start hearing inferior BPDUs. Now, the LoopGuard has been enabled on this port, and this port, fast-internet 20, was in a blocking state before this operation. But if I do show spanning tree now, I will see that this port is actually now transitioning through listening and learning phases and is going to become a designated port in a forwarding state in the end. So the LoopGuard in this particular scenario here really didn't do anything. Why didn't it do anything? Because when this link went down, Cat2 lost its own superior BPDUs, and that, because this was a direct failure of the link, happens immediately. Cat2 immediately runs its own local route election and it determines it's the route and starts sending its own BPDUs. This port here, therefore, did not experience a sudden loss of BPDUs. Therefore, the LoopGuard won't kick in this case. The next example is also going to be an interesting one. What I'm going to have here is I'm going to have LoopGuard enabled on fast-internet 20, just as I had before. But on Cat2, I'm simply going to turn off the spanning tree. What is this going to do to my network? Now, remember that this port here was the root port and this port here was blocking. Now, with this change, these BPDUs that are arriving from Cat1 are going to be arriving normally. But these BPDUs that are being sent towards Cat2 are not going to be flooded by Cat2 adding its own cost, changing the sender ID to its own addresses, but instead they're going to be switched out with the original parameters as they were when they were sent by Cat1. Now, when this happens, when these two frames arrive to Cat3, what's going to happen is that these port roles are going to be reversed. Why? Because this is going to have the same root ID. It is going to have the same sender ID, which means that we have to go down to the actual port ID for determining which one of these is superior BPDU. And Gigabit interface will actually win over the fast Ethernet 22. So what we should have here is reversal of roles, that this is going to become a blocking port and this one here is going to become the root port. Let's take a look at that. So I'm going to go to my terminal and I'm just going to confirm that this is actually the state now. I have two interfaces, fast Ethernet 20 is blocking and fast Ethernet 22 is forwarding. I can also confirm that fast Ethernet 20 has LoopGuard enabled right here, and I'm going to confirm that my debug is still running. Now I'm going to go to Cat2 and I'm going to say no spanning tree VLAN 1. Let's go to Cat3 and let's see what is happening. I can see immediately that fast Ethernet 20 is now transitioning into a listening phase because it is receiving a superior BPDU. Fast Ethernet 22 moved into blocking state. So if I repeat my show spanning tree here, now I indeed see that the roles have been reversed. Now let's try to make our LoopGuard actually do something in our network. To do that, I'm simply going to shut the link down between Cat1 and Cat2. Now remember, I'm receiving superior BPDUs here from Cat2. And with this link being shut down and spanning tree being turned off on Cat2, I'm going to have a sudden loss of BPDUs. But it will take 20 seconds for this to be detected because this is an indirect failure. We have to wait for max age time to expire. So I'm going to go to Cat2, I'm going to say interface gigabit 01, and I'm going to shut it down. Let's see what happens now. Remember, we have to wait for about 20 seconds now. So I'm just going to do show spanning tree now and see what is happening. Fast Ethernet 20 is still root port. It doesn't know that BPDUs are not arriving. Well, actually, the timer is going down, and now this is what we have. We got the topology change notice on Fast Ethernet 20, but the important message is this one here. The LoopGuard has actually blocked this port. Why? Because BPDUs suddenly disappeared. Let me turn off the debug and let's take a look at more details here. So I'm going to do show spanning tree inconsistent ports. I'm going to see that Fast Ethernet 20 is now in a loop inconsistent state. How can I recover from a loop inconsistent state? Well, in this scenario here, there are two ways. One is simply either enable the link between Cat1 and Cat2 or turn on spanning tree on Cat2. I just need to receive a single BPDU from Cat2. If I receive a single BPDU, this loop inconsistency will be cleared. But what if that was not an option? Well, one of the things that I can do is I can go to Fast Ethernet 20, which is now being blocked anyways. If I do show spanning tree, I'm going to see here that it is in a loop inconsistent state. There is no traffic going on here. So what I can do is I can simply shut it down. Now, when I've shut down this port, and if I do no shutdown, what's going to happen now is when this port now goes up, it's going to transition from disabled state into becoming a designated port. So if I do show spanning tree now, I will see here that the port now operates normally. Why? Because when we shut down the port, we are going to clear out all the errors that existed on this port as far as loop inconsistency goes. When we transition the port up, the port is going to listen for incoming BPDUs. If there are no incoming BPDUs, it is going to assume that on the other side there is no switch, and we can transition normally to becoming a designated port. The important thing that I would like you to note in this example here is that it was the root port that was being affected. But can LoopGuard actually protect the port that is blocking from transitioning into a designated port role? Yes, it can, but actually reproducing this is a little bit involved. Now, let me be absolutely clear and say that actually reproducing this is very, very easy. But actually testing this particular behavior is going to be involved for one reason. Let me try to give you an example. So, a quick reminder. LoopGuard is turned on this port. So how can I create a sudden loss of BPDUs here while keeping this port in a blocking state? Well, one of the things that I could do, I could shut this link down and turn off spanning tree on this switch here. But no matter in which order I do this, this port is going to transition into some different state. Why? If I start by shutting this link down, remember what's going to immediately happen on Cat2. That was the first example. A BPDU is going to be sent by Cat2, and this will be an inferior BPDU. This will cause this port here to transition to become a designated port. Now, what if I started by first turning off spanning tree on this port? What's going to happen? Simply, this BPDU here is going to be forwarded, and this port is going to transition to become a root port. That was our second example. No matter how fast I am on my command line, the switches are going to be faster than me, except if I went down the road of changing the timers. But what I'm going to do here is I'm going to use a feature that I'm going to talk about in greater detail in my next video. And that feature is simply going to prevent Cat2 from sending any BPDUs. So I'm going to use a feature called BPDU filter on Cat2's Fast Ethernet 20 interface. As I said, I'll talk about it in greater detail. This feature is also very complex and you need to understand it in great detail. But for now, let's just assume it simply blocks any outgoing BPDUs. I don't care about the incoming BPDUs to Cat2. So if I configure the BPDU filter on Cat2, suddenly Cat3's port, which was a blocking port here, is going to stop receiving BPDUs. When it stops receiving BPDUs, it should transition to become a designated port unless LoopGuard prevents it from doing so. So let's jump into our terminal and confirm that spanning tree operates as we expected. I can see here that Fast Ethernet 20 on Cat3 is blocking port, and on Cat2 everything is as normal. Gigabit 01 is the root port and Fast Ethernet 20 is the designated port. On Cat3 here I have no debugs turned on, but on the interface Fast Ethernet 20 show spanning tree interface Fast Ethernet 20 detail. Oh, typos. I can see that LoopGuard is enabled on the port. So now on Cat2 I'm going to say spanning tree BPDU filter enable. This is going to cause the BPDUs to suddenly stop being sent. If I do show spanning tree interface Fast Ethernet 20 detail, I'm going to see here that the received count for BPDUs is not increasing. You can see that I'm not receiving any BPDUs, and after 20 seconds, simply the LoopGuard kicks in. I can also see here that the port, when this happened, was actually in a blocking state. So the sudden loss of BPDUs that were there caused this port to now move into a loop inconsistent state. So let's remove the filter here and let's see what happens on Cat3 now. We can see that almost immediately port actually was unblocked by the LoopGuard. But this doesn't mean that the port is immediately forwarding. The port now needs to go through its usual motions. It is either going to go into becoming a listening and learning port if it needs to transition to forwarding state, but that's very unlikely to happen unless we received an inferior BPDU. If we received an inferior BPDU from Cat2, this would happen. But we received a superior BPDU, which means that this port needs to go into blocking state. Let's repeat this exercise here. So I'm going to configure the BPDU filter. I'm going to cause Cat3 to start blocking this port. But in the meantime, I'm going to shut the link down between Cat1 and Cat2. So now we can see that the LoopGuard actually blocked the port as the result of my BPDU filter configured. So now let's remove the BPDU filter from this port, and when we receive the first BPDU, this will be the BPDU generated by Cat2, which is going to be an inferior BPDU, and we can see that this also caused the port to move to become to move out of the loop inconsistent state, but now this port needs to become a designated port, and we can see that it is going to transition through the normal spanning tree phases. The next thing that I'm going to show you is going to be very quick and simple. On Cat3, I have enabled spanning tree LoopGuard on a port, and I can see and confirm that this is actually running. If I do show spanning tree interface Fast Ethernet 20 detail, I will see that the LoopGuard is enabled on the port. Let me turn it off. So I'm going to say no spanning tree guard loop. If I rerun my show spanning tree interface Fast Ethernet 20 detail command, I will see that there is no mention of the LoopGuard anymore. I can enable spanning tree LoopGuard globally. The command for that is spanning tree LoopGuard default. Now I have turned on the LoopGuard on all the ports. If I do show spanning tree interface fastnet 20 detail, I will see that the LoopGuard is enabled on the port. But you will also remember that I mentioned that the LoopGuard and the RootGuard are mutually exclusive. So which one wins? Well, the last one that is configured on a per port basis will win in a case of a competition there. So to show you this, I'm going to turn this off, the global configuration of the LoopGuard. And I'm going to go to interface fastnet 20 and I'm going to say spanning tree guard, and I will show you that I have three options: none, loop, and root. Well, none is very simple. I'm going to turn off either guard. So if I configure the LoopGuard, I'm going to end up with the LoopGuard enabled. If I configure root, I will end up with the spanning tree RootGuard enabled. But what happens if, for example, I have a RootGuard configured on a per port basis, like this, and this is the only way to configure the RootGuard, and I have a LoopGuard enabled globally? Well, in that particular case, the local configuration on a port will win. That means that the more specific configuration, that one of the RootGuard, will defeat the globally configured LoopGuard. If that is the situation and on a particular port you still want to use the LoopGuard, you simply have to remove the RootGuard configuration. Simple as that.